Hey everyone. All right. So we are at the very last part of the unit. We are talking about quadratic still, but now we're going to apply them to real world situations. Okay. So we're going to determine the domain and range of quadratics, and then we're going to sketch graphs for those quadratics. All of those being in a real world situation. Okay, so the very first one that we're going to approach is that whenever we are talking about an archer, so someone that shoots a bow and arrow, they shoot it from a height of 5 feet. It follows the path made by the quadratic function h of t equals negative 3t squared plus 8t plus 5. And t is going to represent the time in seconds from when the archer shot the arrow, and h is the height in feet. Okay, so we're going to sketch a reasonable graph of the problem situation. So we're going to label our x and y axis. Okay, so hang on just a second. The first thing we need to do is determine which one is going to be our x-axis and which is going to be our y-axis. So we know that h of t means that t is what's going to determine the h, the height. The height is going to be our dependent variable. So that's going to be our y-axis, and our time is our independent variable. That's the thing that's going to cause something to happen, okay, something to take place, okay? So time is our t, and height is our h of t, okay? Input and output. All right, and so we need to also know what's going to happen with this thing. So let's graph what we see right here. We see h of t equals the negative 3t squared plus 8t plus 5. And we have to remember that we can't graph a t. We don't have a t-axis here. We have an x-axis. So let's graph a negative 3x squared, let's see, plus 8x, not an 8t, but an 8x plus 5. Okay, I'm getting better at remembering the x's, right, instead of the other ones. All right, so there's our graph right there. Okay, we can't tell a whole lot about it just yet, but we do know that our calculator will help us out on some of the things. So we need to know a couple things. We need to know where it crosses the y-axis here. So let's do menu, trace, graph trace. What that tells us is at 0, 5, that is our y-intercept. Okay, so it's 1, 2, 3, 4, 5. So I know that that's where that thing's going to start, right? All right, I also need to know where this thing is going to hit the ground, right? Okay, so I'm going to do menu, analyze graph, and 0 because I want to know how long it's going to take for it to get there and hit the ground. We've done these types of problems before. We know the questions it's going to ask. All right, so that tells me that it's going to be a little past 3. So I'm trying to just set up my graph here is all I'm doing. Okay, this is 1, 2, 3, 4. This is 1, 2, 3, 4, 5. I'm going to keep going. 6, 7, 8, 9, 10. Okay, 6, 8, 9, 10. Okay. And let's see what our maximum is, because we have one of those here. Menu, analyze graph. Let's find the maximum. I'm going to click, drag, click, and that tells us that our maximum is at 10.3. Okay, good. So we have a couple of things here that we can sketch our graph. We can use those things and we can sketch this graph. Let's see what color we want to use. Let's use green. Let's use this pretty green. All right, so I know that I have a point right here and where it's going to end up. I know it starts right here. I know I have a right about right here is where my vertex is. It's where my maximum is, right? All right, so I'm just going to sketch this thing right here. See how this works. Okay, so realizing that this is the real world, that's the only part of the graph that I'm going to sketch. Okay, and I'm going to label these parts. This was, let's see, 0, 5. this was, what was it, 3.19. I'm going to erase these out of the way. .190. All right, and then this point up here was 1.33, 10.3. All right, so I think we have a lot of information there that we can use. All right, so we want to know what is, or they want to know, what is the independent variable and what does it stand for? Well, we talked about that whenever we were setting this up, and we said that t was our independent variable, and what it stood for was the time in seconds that it took for the arrow to hit the ground. I'm just going to write time in seconds so we know what the other part is. All right, and so if we talk about the least amount of time that it makes sense for the problem, we're talking about when was the arrow shot? Okay, that's what we're talking about. When was the arrow shot? At what second? What was the minimum amount of seconds that the arrow was shot? Okay, and that was at 0 seconds. Okay, and then this says what is the greatest amount of time that makes sense for the problem? Okay, well, it hit the ground when? At 3.19 seconds. So we're going to say 3.19 seconds. Okay, so what that's doing, it's leading us up to figure out what the domain of this problem is. And so we know that the smallest amount of time was 0. The biggest is 3.19. All right, and we know that t is going to be here in the middle. So it's going to include 0 all the way up to 3.19, and it's going to include 3.19 seconds. That is your domain, okay? The least amount is 0 seconds. The biggest amount is 3.19. When it hits the ground, time stops. We're done, okay? All right. So now, dependent. Dependent means it depends on something else. Okay, so let's switch colors here. We said that h of t was our dependent variable. It stands for height in feet. All right, and be careful with this next question. It says, what is the lowest height of the arrow? You have to remember, hits the ground, okay? So when it hits the ground, how many feet? What's the lowest height of the arrow? Well, that's at 0 feet, right? Okay. So then we want to know, what is the greatest height of the arrow? Well, we found our maximum, right? Our greatest height was at 10.3 feet, right? So the greatest height was 10.3 feet. And we found that at our maximum. All right, so now to find the range of the problem situation, we would say that the least amount, the smallest amount, the smallest height of the arrow would be 0. The biggest, the highest would be 10.3. And so we're saying that our range is from 0 to 10.3. Okay. All right. Last set of questions here, and it wants to know at what time does the arrow reach its maximum height? Well, that's the t value, right? That's 1.33, right? All right, so it reaches the maximum height at 1.33 seconds. All right, so how many seconds? At what time does the arrow hit the ground? Well, right here, 3.19 seconds, right? All right, and then we want to know what the y-intercept of the graph was. Well, we found that early on. It was 0.5, wasn't it? Absolutely. And that's because the arrow was 5 feet off the ground. That's where it started, right? And then the x-intercept of the problem solution was where it hit the ground, 3.19 0. That is at 3.19 seconds. All right. I hope all of that made sense because it kind of brings everything all back together. Now we're going to have one more problem like this. That's going to be in another video because it takes a little bit of time to explain all these. All right, so I'll see you on the next video. Hopefully you'll be able to do some of those. Okay? All right. See you soon.